This question is based on Young's double slit experiment. So in the case of Young's double slit experiment, there will be two slits and we'll have a screen. Here will be a source. So from the source, light will come and that will pass through both the slits and that will interfere and forms a interference pattern on the screen. Now the distance between screen and slit, let it be capital D, and distance between the slits, two slits, let it be small d, and here they have given the values of capital D, that is 1 meter, small d 1 millimeter, and if you consider a point which is in the middle of two slits, and if you put a straight line, you will get another point on the screen. At this point, we'll get maximum intensity because the path difference is 0 at this point. When the path difference is 0, we'll get constructive interference. So we'll get a maximum intensity here. So let's consider the intensity at this position is I max. Now, at y distance from this point, we are getting an intensity that is I max by 2. So these are the informations given. Based on that, we need to find this y value. And yeah, lambda is also given. Lambda is 5000 angstrom. So 5000 into 10 power negative 10 meters. Fine. Now, if you remember this Young's double slit experiment derivation, then in that case, we can write the path difference as like delta x, which is y small d by capital D. So this derivation is available in the book. You can have a look. Here the idea is like you have to find this length, the distance between first slit and this position. Similarly, you have to find this length also, and if you subtract both of them, and if you do slight approximation, then you will get this one. So I have just written it. I am not going to derive now. So I have just taken the result. So this is the first part. Now, also we should know how to write the intensity when two waves are interfering. So consider like first wave is A cos omega t, and second wave is having same amplitude but uh, with slight phase difference. So this phi is the phase difference. When these two waves interface, we'll get a new wave that we can write it like this, y1 plus y2. So in this case, it is going to be cos omega t plus cos of omega t plus phi. So it is in a form which is cos A plus cos B. Cos A plus cos B. So cos A plus cos B is 2 into cos of A plus B by 2 and cos of A minus B by 2. We'll use the same idea here. Let's consider this one as A, omega t plus phi is A, and this is B. So what do we get? We will get this y is equal to 2A cos of maybe 2 omega t plus phi by 2 and cos of phi by 2. So this is what we get. Here, if you look at carefully, the one cos function depends on the time, which is responsible for this oscillatory motion. And another one is going to contribute for the amplitude part. So we can write the net amplitude as 2A cos of phi by 2. So the thing what we have to understand is the net amplitude depends on this phase difference phi. So for certain phase difference, it is possible to get zero amplitude also. That's what we need to understand. Now using this, we can write the intensity. So intensity is square of the amplitude. If I write, then I will get, maybe let's consider A squared equal to I0. Okay. Then we will get 4A squared cos squared phi by 2. Yeah. So to find the net intensity, we need to square the amplitude. I net equal to A net squared. Okay. So that's what I did here. And we can consider this A squared as I0. I0 is the wavelength of the first wave, cos squared phi by 2. Now the cost function maximum, it can have a value that is equal to 1. When it reaches the maximum value, then we'll get the maximum intensity. Okay, so the maximum intensity Imax, I can write it as 4I0 times 1, because the cost function at the max it can take the value 1. So maximum intensity is 4 times I0. I0 is the intensity of a single slit. Like these two slits will act like a point sources. So what is the maximum intensity that we can get through one slit? That is I0. Now when both of them are interfering, when we get the brightest uh, fringe or constructive interference, there the intensity is going to be 4 times of individual one. So that's what we need to understand. Now we can rewrite this intensity one. Instead of 4I0, I can write Imax. Imax times cos squared 5 by 2. Some textbook or in some study material, they used to give this expression also, but I just derived it. Instead of remembering, sometimes you try to derive it. So now, yeah, this we have taken. Let's substitute the given information in this equation. The given information is we need to find a distance, this y value, where the intensity is half of the maximum intensity. So let me substitute and figure out the phi value. So I equal to Imax by 2, that is Imax cos squared 5 by 2. Imax gets cancelled. So 1 by 2 will become cos squared 5 by 2. Let's take a square root. 1 by root 2 equal to cos of 5 by 2. So cos 45 degree is 1 by root 2. 45 degree means pi by 4. So pi by 4 will become pi by 2. From this we can find phi, which is pi by 2. So we found the phase difference and we have written the path difference. Now we need to equate both. So phase difference is equal to 2 pi by lambda times path difference. This is a relation between phase difference and path difference. Let's substitute phase difference pi by 2, which is equal to 2 pi by lambda. This path difference we should remember for the Young's double slit experiment, y small d by capital D. Okay, we need y only. Let's cancel this pi. Y will become lambda d by 4d. I think we have all the data. Let's substitute one by one. This is 5000 into 10 power negative 10. 1 meter. This is 1 millimeter. So 1 into 10 power negative 3 will become 125 into 10 power negative 6 meters. Is it 1 millimeter? Yeah. 5000 angstrom. So we are getting y value as 125 into 10 power negative 6 meter. So at this y value, we are going to get an intensity that is going to be half of the maximum intensity. So yeah, here in the uh, question, they are asking this one only. So we can write it as 125 because 10 power negative 6 is given. So this answer is 125. So here you have to look at carefully how we are approaching this question. So first we are writing the path difference. Then using intensity information, we are finding the phase difference. Okay, this is the intensity expression. With that, we can find the phase difference, and you have to use the relation between phase difference and path difference. From that, we can find the y value. That's all.